Okay, so this video we're going to look at questions 7 through 9 on lesson 6.1. So the first thing I want you to do before we start answering question number 7 is just to remember what your even, odd, and neither parent functions are. So we're just talking about parent functions and which ones are even, odd, or neither. And remember, even symmetry comes from symmetry over the y-axis, odd is over the origin, and neither would have neither symmetry. Okay, so take a second, write your answers down. And pause the video if you need to. Okay, so our even parent functions, we have 3 of them. They're going to be absolute value, quadratic, and quartic. Alright, notice all of those have a vertex that lies on the y-axis. Our odd parent functions are going to have a point of symmetry at the origin, so that's going to be cubic, linear, and rational. And then the 3 remaining ones that we haven't talked about yet that doesn't have any symmetry are going to be logarithmic, exponential, and square root. So make sure you put that on the side of your page so that you have a reference to it. Okay, so now we're going to look at question number 7, and what we're going to look at is how transformations affect a function being even or odd. So just keep in mind that a parent function can only stay keep the type of symmetry it started with. So x cubed could only be an odd function unless the transformation changes that symmetry. Okay, so on these, what you're going to do is you're going to draw your sketch. So let's do A together. So on A, I have a cubic that's being translated up 1, so that inflection point moves up to there, and now we have this. So I can see where I normally have the symmetry of those 2 parts of my graph, that's above the origin now. So it's no longer has that symmetry that I'm looking for. And so this, even though it was originally an odd function, because I moved it up 1, it now becomes a neither function. So what I'd like you to do for B, C, D, E, and F is draw your graph, identify the type of symmetry, and then whether it is even, odd, or neither. Okay, so here are my sketches, and you're welcome to have used a calculator to figure these out. But let's go ahead and talk about this one. On B, a quadratic is typically an even function, and notice that when I shifted it down 3, my vertex still stays on the y-axis, so that still gives me symmetry over the y-axis, which means that it's going to remain an even function. On C, if I'm raising something to the 5th power, I'm going to produce a graph similar to a cubic graph, and since that inflection point is still at the origin, I have symmetry about the origin, which means that it's an odd function. D is just your absolute value graph, so that's the y-axis, means it's even. On E, even though this is a quadratic raised x squared, the vertex is over here now in quadrant 4, and so if I look at the y-axis, I don't have symmetry in the graph about the y-axis anymore. So even though the graph might have symmetry, it's been shifted off the y-axis. So it's somewhere like x equals, I don't even know what it might, maybe 2.5 or something. I don't know exactly where it is unless I looked for where that vertex was located, but it's not the y-axis. So because it's been shifted off the y-axis, now this, what typically would be an even function, now classifies as neither. On F, this is a rational squared, and so whenever you square your rational, you get your curves and side by side, and because it's negative, it flips down to the bottom, and so I can see that I have the symmetry over the y-axis, which makes this an even function. Okay, so if you haven't already, make sure you get your notes or correct any mistakes that you might have made. Okay, so the next thing we're going to look at is on the same page. It's this little box up in the right-hand corner that says math term, and this gives us an algebraic definition of even and odd. So I'm going to take these 2 definitions and move them to the next page on question 8 and 9. For even, we know that f of negative x equals f of x. And then for odd, f of negative x equals negative f of x. So I'm going to just write those underneath question 8 and 9. Question 8 is the even, so f of negative x equals f of x. And then the odd one was f of negative x equals negative f of x. So let me explain what this means. So for an even function, if I input an x, I get an output. If I input a negative x, I get the exact same output. So let's look at an example to understand what's going on. So let's look at the example f of x equals x squared. If I input a positive 2, 2 squared equals 4. If I input a negative 2, remember anytime you square a negative, it becomes a positive answer, so my answer is still positive 4. So notice that even though I had opposite inputs, my output was identical. So what I'd like you to do over here on the table is they've given you 4 x values. What I'd like you to do on the bottom is use the opposite x values, just change their signs. If it was negative, make it positive, and vice versa. And then predict what you think the output should be based on using the opposite x of what you already used. So go ahead and pause the video and complete the table. Okay, so here's the answers that you should have got. We should have changed our inputs to 2, -1, -5, and -9. And so notice that the outputs that go with those x values are the exact same outputs that went with the opposite x values. So that is going to produce your even function. All right, and again, quadratic is a perfect example to think of it. You're on opposite sides of the y-axis, and your y values are the same for opposite x's. All right, so let's look at the definition for the odd function, question number 9. When we input a negative x, we get out a negative y. Okay, let me change that a little bit. When we input the opposite x, we get out the opposite y, because sometimes negatives don't always go together. So the best example to look for this is to use the cubic function, x cubed. Okay, so let's use 2 again. So we're going to say the function of 2. So I'm going to cube 2, 2 to the third power equals 8. Now if I change that 2 to the opposite sign, which is a negative, I get negative 2 raised to the third power. Remember, anytime I have a negative raised to the third power, I'm saying negative 2 times negative 2, which is positive, times another negative 2, which makes my answer negative. So negative 2 cubed is negative 8. So notice the output has the same numerical value, just opposite signs. All right, so whenever we're doing this, we're going to use our negative x over here in the table, or the opposite x. We should expect to get the opposite sign. So again, pause the video and complete the table, similar to what we did on table 1. Okay, so let's check your answers. So when I created the rest of my table using the opposite x's, I would have the same y, just the opposite sign. So the point, instead of being at -4, -60, was now at 460. And you can see that the signs changed. Alright, so that's looking at even and odd from a graphical standpoint as well as a tables and numerical standpoint. Go ahead to complete the rest of this packet. Go ahead and look at the next video for questions 10 through 14.